Hello, this is a separation logic for heap space under garbage collection. I am François Pottier and this is joint work with Jean-Marie Madiot. Our goal is to establish verified bounds on a program's heap space usage in the presence of a tracing garbage collector. We want to use a program logic, and it seems natural to view heap space as a resource. We introduce a new assertion, one diamond or one space credit, which can be understood both as a guarantee that there exists one word of free space in the heap and as a permission to allocate one word. Without GC, this approach works. In the presence of GC, deallocation becomes implicit, so it is no longer clear where and how we might recover space credits. It's tempting to view deallocation as a logical operation, a ghost operation, which one would explicitly invoke while verifying the program. One could present deallocation, as shown on the slide, as a ghost state update, which means that by abandoning a points-to assertion, one gains a number of space credits. This formulation has some good properties. No double free, no use after free. Unfortunately, it is not sound. By making deallocation a ghost operation, we create a distinction between the logical heap that the programmer has in mind, where deallocation is explicit, and the physical heap that exists at runtime, where deallocation is automatic. For the logic to be sound, these heaps must have the same reachable fragments, a property that is violated in this diagram. To enforce this property, we must restrict logical deallocation by imposing the condition that only unreachable blocks can be deallocated. This may seem problematic at first, because traditional separation logic is designed to reason about ownership, not about reachability, which is an unrelated concept. Our solution is to keep track of the predecessors of every block using pointed-by assertions. A block with no predecessor is unreachable, therefore can be logically deallocated. In summary, points-to assertions allow reasoning about ownership and can be viewed as permissions to read or write a block. Pointed-by assertions allow reasoning about reachability and can be viewed as permissions to create or destroy pointers to a block. The presence of both assertions is required by the logical deallocation operation. There is a lot more in the longer talk and in the paper, including key technical issues such as how to identify the GC roots and how to state the soundness of the program logic. We also present examples of verified functions and specifications. Thanks for watching, and if you're interested, do come and talk to us online at Pottier.